Hi everyone, my name is Molly and today I'll be showing you how to find the local maximum and the local minimum for the equation f at x equals to x cubed divided by x squared minus 4. So there are 3 steps to do this. The first step is to set the first derivative equal to 0 to find the critical points. In the question we're already given the first derivative and we set that to 0 to find the critical points of x equals to 0 and x equals to plus or minus square root of 3. And then we sub in these x values into the initial equation of f at x to find the y values. And as you can tell, the critical points are 0, 0, 2 root 3, 3 root 3, and negative 2 root 3, negative 3 root 3. The second step is to find the intervals of increase and intervals of decrease. So we're going to be drawing a number line and plotting the important critical points, as well as vertical asymptotes, which are at x equals to negative 2 and x equals to 2. Then for each interval, we're going to be finding a number that fits under the interval and sub it into the equation for the first derivative. And if the first derivative is less than 0, then it means that it's an interval of decrease. And if the first derivative is greater than 0, then it means that it's an interval of increase. So for example, between negative infinity and negative 2 root 3, that interval specifically, we can take x equals to negative 4 and sub it into the equation for the first derivative that equals to 4 over 9, which shows that the first derivative is positive and therefore an interval of increase. And so we apply this to every single interval, and the only intervals that are intervals of increase are at 2 root 3 and negative 2 root 3, and everything else is an interval of decrease, meaning that there's only one max and one min. So moving on to step 3, finding the local maximum and the local minimum. For the point negative 2 root 3, this is an increase followed by a decrease. So change from an increase to a decrease will dictate that it's a local maximum, as you can see over here. And for the last point, we have 2 root 3, and this is a decrease switching into an increase, which dictates that it is a local minimum. And for everything else, there is no other local maximum or local minimum because it's a consistent decrease and there's no change from decrease to increase or increase to decrease. To summarize this visually, in the first part of the test, we had to graph this equation. So as you can tell, the local maximum is negative 2 root 3, negative 3 root 3 at the bottom right over here. And the local minimum is 2 root 3, 3 root 3 at the top over here. Thank you for watching this video, and I hope this makes sense.